You have probably seen a black hole explained as the universe's vacuum cleaner. Something gets too close, it falls in, and that is the story. But that version is too simple, because black holes are not just monsters that swallow stars. They sit at the center of galaxies. They bend time. They launch jets longer than entire galaxies. And some scientists have asked a much stranger question: what if some black holes are not just inside the universe? What if some of them are part of the missing matter holding the universe together? That question sounds wild, but it comes from a real problem. Most of the universe is missing. When you look at the night sky, almost everything you see is ordinary matter. Stars, planets, dust, gas, your body, every atom in every mountain, ocean, phone screen, bone, and breath. And still, according to NASA and CERN, ordinary matter makes up only about 5% of the universe. Dark matter makes up about 27%. The rest is something even stranger called dark energy. So the first uncomfortable truth is this: the universe we can touch is not the main universe. It is the visible crust. Dark matter does not shine. It does not reflect light. It does not absorb light. It does not interact with the electromagnetic force in the normal way. That means you cannot simply point a telescope at a patch of space and see it glowing there. But you can see what it does. You can see galaxies spinning too fast. You can see light bending around invisible mass. You can see galaxy clusters behaving as if a hidden skeleton is holding them together. The problem is not that scientists invented dark matter because they wanted a mystery. The problem is that the math kept pointing to mass that no telescope could see. And this is where black holes enter the story. Because black holes are dark. They have gravity. They are real. We have seen their effects for decades, and in 2019, the Event Horizon Telescope gave the world the first image of a black hole's shadow in the galaxy M87. So the question almost asks itself: if the universe is missing matter, and black holes are invisible objects with huge gravity, could black holes be the missing matter? The answer is not a clean yes. It is much more interesting than that. The dark matter problem became impossible to ignore because of galaxy rotation. In 1970, astronomer Vera Rubin and instrument maker Kent Ford studied the Andromeda galaxy. They expected the outer stars to move more slowly than the stars closer to the center, just as planets farther from the sun move more slowly than planets closer in. But that is not what the data showed. The outer parts of Andromeda were moving far too fast, not a little too fast, fast enough that if only visible matter existed, the galaxy should have been unstable. The stars should not have behaved as if everything was normal. Rubin and Ford were not looking for a cosmic ghost story. They were measuring motion. But the motion kept saying the same thing: there is more gravity here than visible matter can explain. That became one of the strongest clues for dark matter halos around galaxies. Think about what that actually means. A galaxy is not just a bright island of stars. It is surrounded by a huge invisible envelope of mass, extending far beyond the glowing disk you see in space images. The pretty part is not the whole galaxy. The pretty part is the small visible wound left by something much larger. But here is where it gets stranger. Dark matter does not just appear around single galaxies. It appears when entire clusters collide. In 2006, a team led by Douglas Clow studied the Bullet Cluster, officially known as 1E0657558. This was not one galaxy. It was two giant clusters of galaxies that had smashed through each other. NASA's Chandra X-ray Observatory showed the hot gas from the collision. That gas is ordinary matter. It is made of atoms. In galaxy clusters, hot gas contains most of the normal matter, but gravitational lensing showed something else. The strongest gravity was not centered on the hot gas. It was offset. The mass had separated from the normal matter. Clow's team described this as direct empirical evidence for dark matter, because the gravity followed the galaxies, not the X-ray gas. In their paper, they reported an 8 sigma separation between the visible baryonic matter and the total mass peaks. That is not a small hint. That is the universe putting the invisible thing in a different place from the visible thing, and black holes cannot easily explain that on their own. Normal stellar black holes form when massive stars die, but dark matter had to influence structure formation very early, before many stars had time to live, die, and make black holes. If dark matter built the cosmic web first, then ordinary star death black holes arrived too late to be the whole answer. So scientists had to imagine a different kind of black hole, not black holes born from stars. Black holes born before stars, these are called primordial black holes. The idea goes back to the early universe. In the first moments after the Big Bang, density was not perfectly smooth everywhere. If some regions were dense enough, gravity could have crushed them directly into black holes long before the first stars existed. That would make primordial black holes very different from normal black holes. They would not need stars. They would not need galaxies. They could have been there from the beginning, scattered through space like invisible seeds. And if enough of them existed, they could behave like dark matter. This is the version of the idea scientists take seriously. Not every black hole we see is dark matter. That is too simple. The real question is whether a hidden population of ancient black holes could make up some fraction of dark matter. In 2016, NASA scientist Alexander Kashlinsky suggested that primordial black holes might connect two mysteries: the cosmic infrared background and the cosmic X-ray background. His team argued that infrared light from the first stars and X-rays from gas falling into early black holes could explain patterns seen in the sky. It was not proof, but it made the idea harder to dismiss. Then gravitational waves made it louder. In 2015, LIGO detected gravitational waves from two merging black holes. They were heavier than many people expected for such a first detection. Suddenly, scientists started asking whether some of these merging black holes could be primordial. That does not mean LIGO found dark matter. It means LIGO opened a new way to test the idea, and tests matter, because the universe is not allowed to be interesting without being annoying. Every mass range for primordial black holes faces constraints. If they are too small, they may evaporate through Hawking radiation. If they are star-sized, gravitational wave data, microlensing surveys, and cosmic background measurements limit how many can exist. If they are too common, they would leave signatures we should already have seen, a 2024 analysis by M. Andres Carcassona and collaborators used LIGO Virgo Cagra 03 events to constrain primordial black holes in the 1 to 200 solar mass range. Their result was harsh for the idea that those black holes are all of dark matter. In their scenarios, primordial black holes could make up at most about 1,000th of dark matter in that mass range. That does not kill every possible primordial black hole model, but it does close a dramatic door. The universe is not handing us an easy answer. Here is the part that changes the mood. Black holes are not the scariest mystery in this story. The scariest mystery is that black holes are one of the few invisible things we actually understand. We know they exist. Roger Penrose showed that black hole formation is a robust prediction of general relativity. Reinhard Genzel and Andrea Ghez tracked stars around the compact object at the center of the Milky Way, showing that a supermassive black hole is the only known explanation. That work won the 2020 Nobel Prize in Physics. Then the Event Horizon Telescope went even further. In 2019, it imaged the black hole in M87, about 55 million light-years away, with a mass of about 6.5 billion suns. In 2022, it revealed the first image of Sagittarius A, the black hole at the center of our own galaxy. Black holes are terrifying, but they are not fantasy. Dark matter is different. Dark matter shapes galaxies, bends light, and helps build the large-scale structure of the universe. Yet we still do not know what it is. It may be a new particle. It may involve axions. It may involve weakly interacting particles. It may include a small contribution from primordial black holes, or our understanding may still be missing something deeper. That is the darker truth. The universe is not hiding one monster. It is hiding the rules. This is where the story comes back to you. Your entire life happens inside the 5% layer. Your room, your food, your memories, the ground under your feet, the sun in the sky, all of it belongs to the small visible portion of reality. And yet the structure that made galaxies possible seems to be controlled mostly by something you will never touch, never see, and maybe never directly detect with your eyes. That should change how space feels. The universe is not empty, it is loaded with invisible architecture. Galaxies are not floating freely like glitter in darkness. They are caught in a web. They move inside halos. They gather where invisible gravity has already prepared the stage. Black holes make the story more personal because they feel like objects. They have edges. They have shadows. They can be photographed indirectly. You can point to Sagittarius A and say, there, that is real. Dark matter does not give you that comfort. It only gives you consequences. So, are black holes dark matter? Some may be part of the story, most probably are not the whole answer. And maybe that is why this question is so powerful. It does not replace one mystery with another. It shows you how the mysteries overlap. Black holes teach us that nature can create places where light fails. Dark matter teaches us that nature can create structure without showing its face. Together, they reveal something humbling. The universe does not owe us visibility. It does not have to glow to be real. It does not have to touch our senses to shape our lives. It can hide most of itself in silence, while the little visible part spins, burns, collapses, and wonders what is holding it all together. And maybe the strangest thing about the universe is not that so much of it is dark. It is that the dark part built a place where we could ask about it. If you like curious science told without the noise, stay with the channel.